Hi, in this video I will give a little look under the hood at Docker. In previous video I just went over the top and just showed you what Docker can do in command lines, and now it's about wondering how that actually happens. Um, so what is Docker? Well, there needs to be a bit of a history lesson about the way that we have tried to build and develop systems. Way back in the past, we would actually get a physical hardware. We would get a rack, say a U1 rack, which is a physical computer. We would plug it into our system. We would get our operating systems and install it. We would then patch it. We would then get all the software needed, and then we would get our code that we want to run and put it on there and keep tweaking with it and messing with it and getting it working until eventually our app was up and running. And then we would need to maintain it. We would have to uninstall, get the latest operating system. Well, putting a new operating system is a format and reinstall, getting the software back on there, and then getting our program code back on there and getting it up and running. So generally, what happened was you would get another server that you would be upgrading everything. You would generally get a better spec machine at the same time, and this whole process would keep on happening. Um, as soon as there was some kind of security problem, God forbid, like an operating system security problem that couldn't be patched, like a Linux problem, um, you were in trouble. You had to provision and try and get them servers up and running. Now imagine you were quite a big operation and you had, maybe 20 machines. Some people have 20,000 machines. That's going to take you a long time. You've got DevOps, you've got system administrators working through the night to get them systems up and running. So um, the idea was to virtualize this so that you could have uh, a virtual environment running a system on top of already existing hardware. And there were virtual machines. Now, a virtual machine consisted really of the whole operating system. So you might have something like Hyper-V that was running on some massive server. You had some beefy machine, and on there you were actually running maybe three complete operating systems. Now, a virtual machine was a full operating system in its own right. It had its own OS, own kernel, all the system that it needed, but really it was pretend. When it was trying to connect, it would connect to a network card, but that network card would be software driven. It wouldn't be a real physical network card. And Hyper-V was the thing over the top of that to really say, that kernel is wanting to speak to that piece of hardware, but actually I'm going to allow it to connect out to the infrastructure here. And that was some seriously complicated way of doing things. At the same time, Linux was also going through some amazing updates in allowing its system to be virtualized. They wanted a scenario where, as a customer, you could give someone a login, and when they log into that machine, they can go /ect /bin, and it would be their local environment. And if they wanted to, they could delete all the content of the bin folder. Be a bit silly, but they could do. But it would be their copy. And another customer would log in and they would get their own virtual environment. And the way that that started working was that instead of having a fully fledged virtual machine that had the whole operating system, the whole system, you had one operating system, and the kernel was able to delegate responsibility and kind of put a firewall in place to say, right, you want to go to / something, well, that's your version. You want to go to C drive? Right, this is your C drive. So customer A, B, and C could all have their own C drive. And one customer could format it and it would only affect them. So we went from quite hefty virtual machines to containers. But there needed to be some orchestration. There needs to be something that gives you this magic. And Docker is one of these platforms. Docker is this system that allows these containers to pretend like they are fully fledged operating systems, but really the OS, the underlying kernel that's communicating with hardware and really doing the work is actually being controlled by Docker. And then Docker passes that down to the environment. Um, Actually, there is normally like a Hyper-V in place that this Docker is running in that's then sitting on top of the host operating system, then on top of the infrastructure. So you could have a massive piece of hardware, you could have some kind of virtualization system, VMware, and in there then is Docker running a Dockerized operating system that's specialized in building and managing containers. Instantly, we can pop along, create a new container within milliseconds, and have our apps running. Now, the reason why the containers take milliseconds is because there isn't an operating system to start up, right? That operating system's already running. The green bit's constantly running. But when you get a virtual machine, you are literally starting up a brand new operating system. And a meaty operating system can take a couple of seconds to a couple of minutes. And then you've got to get the apps firing. Well, Docker, that's already done. All you're saying is container, app, attached to the Docker image, start. And you are talking milliseconds for that to start up. So in the previous example, I had a Docker file, and the Docker file is a script. And in later videos, I'll be explaining the scripting language of a Docker file. But we're saying from this operating system, so Ubuntu with the latest version, um, please run the following commands: apt update and apt install. Apt-get, app install is just a way of installing software on Linux. And then we run a command and then finish. Done. Now imagine this command is to say run a .NET app or run a Node app. That app would then run forever until it stopped. But because the CO command runs and finishes, this container will basically stop instantly. So if I run build this, because we want to create an image of this, so Docker build, give it a name of test, and use the current directory. It'll look in the current directory for a Docker file. I tell you what, it always helps if you're in the right directory. So we build, and then if I say do Docker run test, see that's running. And what I want to do actually is just remove it once it's run, because the container will stay there forever. So Docker run. Perfect. So now I've got an image, and images are a collection. So it's a set of a predefined process. So in other words, I have an image, and if you've ever dealt with like ISO files, an image is just something. I have an image use Ubuntu. It's quite big. I think it's about 500 meg, and the latest version, so the latest operating system from Ubuntu. I could choose to get a particular version if I wanted to. So I could get a 17 or even a 15 version. But latest is a way of being able to say, get the freshest one, which means that every time I build this new image, I am going to get the latest version of Ubuntu. So let's say that, God forbid, there's a security problem with Ubuntu. I have got loads of containers running with that operating system. All I need to do is just rebuild the image. So if I do Docker build, it's going to pull down the latest image automatically. It's going to build a container, and then I'm able to then run that container. And instantly now I have got a very secure version of Ubuntu. My apps have been upgraded. When I started this video, I was talking about you back in the olden days, you would have physical hardware, and if there was an operating system problem that needed a fresh kernel or a new patch, then we would have to apply that patch to all of the systems there were. And that sometimes required restarts, reboots. In some cases, it was so big it required a fresh install of the operating system. Like if we needed to upgrade, like I said there, from version 15 to 16, it would be a complete reinstall, which meant all them thousands of servers that you've got, a system administrator's days spent going and reinstalling each one by one. And that is a serious waste of time. With this, we can have a new image up and running within a couple of seconds. So we have a file which is a Docker file, and that explains what the image looks like. You can also go to Docker Hub and get lots of different images. Once you've got that image, you can create a running container or a container, and you can run it and stop that container. And that then becomes your ecosystem. You can have an image for MySQL, an image for Redis, or whatever kind of system. If you dive over to Docker Hub, you can be able to do a search and pretty much find any kind of software you need that can run as a Docker image. And within seconds, you can have that running on your machine. The video I did previously showed how you can set up a SQL Server and seed it with data and have that up and running in seconds. And this ecosystem and Docker is how we've evolved from hardware to VMs to Docker containers or containerized systems. And then instead of having to write these commands and type these commands out and manage them, they then have platforms of a service like Kubernetes and Pivotal that orchestrate even setting and managing up these containers for us. So the world is getting very clever, but it's based off previous knowledge and previous problems. And that's what Docker's all about. In next videos, I will go into more detail about Docker files, what the structure and syntax is of them, and let's play about with making a Docker file.